Thank you very much for having inviting me. So today I will talk about the structure and evolution of the conjugate Demerara and Guinea transform marginal plateaus. So this is the result of strong collaboration between University of Perpignan, Ifremer-Brest, but also several French universities as Guyane, Brest, Toulouse, Lille, Grenoble, and Total. And you can see here the Demerara and the Guinea plateau. So first of all, what do we call a transform marginal plateau, or TMP? This notion derives from a systematic inventory of transform margins. So you see here on this map all transform margins in the world, which are represented here by black bold lines. And on the basis of this inventory, we could compare some attributes, common attributes of all those transform margins. And on the basis of this comparison, we observed that for about 30% of transform margins, there was a deep planar marginal plateau here between the shelf and the abyssal plane. So it is the case here for Demerara, for the Guinean plateau, but also from other plateaus in the world as Exmouth, Perth, Falklands, Malvinas, and Vorim here, for example. In any sketch, you can see the transform border in yellow. On this basis, we mapped all the TMPs in the world, and we identified 20 of them, which are represented here in red. And what is interesting is when you have a look on continental breakup ages, as here, is that you see that most of them in placed at the junction of oceans of contrasted ages. It is the case in many places, so mostly along ancient rift barriers. So what are the main issues making it interesting to study TMPs? First of all, we can wonder what is the nature of the crust and the significance of those TMPs for the breakup process. And secondly, as you can see here on this reconstruction, you can see that those TMPs, in many cases, form last contact points between continents during the breakup. And we can wonder what is the role of those land bridges on biology and oceanography. So let's have a look to the Demerara TMP case study. Demerara is the conjugate of Guinea. So you can see here a reconstruction at the end of the Jurassic. At that time, Demerara and Guinea were still together, and they were in place in the very southern terminus of the central Jurassic Atlantic. Later on, you can see that those two plateaux individualized in a very oblique to transform mode during the opening of the equatorial Atlantic. So those plateaux record a double history. This is very clear when you have a look on regional cross sections. So you see here first two cross sections here, which are crossing the Demerara plateau towards the Jurassic Central Atlantic here. And what you see very clearly is that there are two breakup unconformities. The first one here in blue, which is Jurassic in age, and you can see another inconformity here, which is Upper Albian in age, and which is consistent with the opening of the equatorial Cretaceous Atlantic. On this cross section, you say the same thing. And on this perpendicular cross section, which is crossing the border, you also see those two breakup unconformity much more involved in deformations. And you also see that the continent to ocean transition is here much more steep and eroded, which is very typical of transform margins. So first, let's have a look to the very oldest remnants of the history of Demerara. So on the Demerara plateau, we identified several seismic units, and the oldest one is Unit A. Unit A is only represented in the very eastern part of the Demerara plateau, forming a sort of basement relict. And you see here the seismic signature of this unit, which is made of a lot of deformations and also high amplitude reflectors. Here is the interpretation. So you see here a system which is highly faulted here by extensional tectonics. And you see also cross-cutting high amplitude reflector. It is the same here, which we have interpreted as included bodies, magmatic included bodies. So we interpret this unit A as probably a node included and deformed crust, making the basement of here Demerara. Above this unit, we identified what we called unit B, that you can see here, which is made of seaward dipping reflectors. And we could identify at least 3 SDR wedges, which are migrating towards west. Here you can see the isopac map of unit B3, and you see very clearly that this unit is thickening going towards the central Atlantic and is pinching out here, going toward the future transfer margin. Here is another nice image about these seaward dipping reflectors. You see that they pinch out here on acoustic basement unit, and that this unit is eroded here by the Jurassic breakup unconformity, which may be an immersion surface in some places. And again, you see that the top of this unit is clearly dipping toward the central Atlantic. More recently, we had a very nice image of the Demerara Plateau using wide-angle and deep penetrating seismic data. So you see here the result of this approach. You see that the Demerara Plateau is made of several units. A lower unit in red here, which is a high velocity unit, above which you find here unit A, which corresponds to our basement included body. And above that, you see here the extrusive system made of SDRs, all dipping toward the central Atlantic domain. So in fact, the Demerara Plateau looks as a volcanic margin. And you can see that the velocities are very close to some very known volcanic margin and are not very compatible with continental crust. Another new information that we got recently is that we got some dredges which have been collected on the transform border of the Demerara Plateau here, which is very steep, and where the basement does outcrop. This basement is probably a prolongation here of unit B. And what we got is very highly outer volcanic rocks, which were dated back to 174 million of years. In terms of geochemistry, they consist in ocean island basalts. So again, we have arguments for a hotspot on the Demerara and Guinea at the Jurassic. After this volcanic margin formation, we also defined some units C and D, which are unlapping this passive margin. And unit D here has been drilled and consists of a carbonate platform. In a second step, all the Demerara and Guinea Plateau have been reworked by the opening of the equatorial Atlantic. And this is well recorded by unit E, which is Barremian to option in age, and which has been drilled. It consists in sands and claystones. And this unit, as you can see here, is very deformed by faults, by strike slip component faults. You also see that this unit is thickening towards some directions, toward north, toward the future transform border, but also toward, you will see it just after, toward the east. This unit is highly deformed by fold and strike slip systems. In the detail, in fact, we can define several segments, some purely strike slip segments, as for example here and there, Typical cross sections are those. So you see a very steep continent to oceanic transition with sometimes some basement ice here, which could correspond to all the intrusive. And we also observe here a more oblique system in this part of the border, where the oceanic to continent transition is a little more wider, reaching 30 kilometers with tilted blocks, as you can see here.
You're at the 10-minute mark, please.
Okay, thank you. Here you see again unit E, which is involved here in this divergent segment, rifted segment, and which is involved in tilted blocks. And on the other side, on the Jurassic margin, you see that unit E here is involved in a very thick gravity tectonic system. Finally, all these units are strongly eroded by the upper Albian unconformity, which seals all deformations. This unconformity has been drilled. It consists in a subaerial surface covered by shell debris. And you see here the geological map under this unconformity. You see on this reconstruction that probably at the time where this upper Albian unconformity was created, Demerara and Guinea were emerged and probably forming a sort of land bridge between America and Africa. We had the chance to compare our observation on the other side, on the Guinean side, and we discovered that we have the same seismic units than on the Demerara side, except one which is not expressed. And we could propose some paleogeographic reconstructions by looking at all this data. So here you see the Demerara and Guinea plateau at the Jurassic forming a volcanic margin with probably two extrusive centers separated by a basement eye. Later on, these passive margins were covered by unit C and unit D here forming a carbonate platform. And in a second step, those plateaus were reworked by the transform dominating opening of the equatorial Atlantic, which is recorded by unit E, which is thickening here in the future transform and here in the future rifted equatorial system. And in a last step, those two plateaus are eroded by the upper Albian conformity. To conclude, our studies show clearly that Demerara and Guinea TMPs formed at the southern end of the Jurassic Central Atlantic as volcanic plateaus. There are many arguments for that. They later separated in a transform-dominated opening of the equatorial Atlantic, probably forming a land bridge at the upper Albian. And it is clear that many TMPs evolved in the same way, at least partly, and that there is probably much more to understand and model about the relation between rift barriers, hotspot activity, and transform initiation. And just last slide, we plan a cruise next fall, again on Demerara Plateau. And during this cruise, we will organize some dive along the continental transform slope in order to visit and sample the Demerara volcanic basement along this very steep slope. Thank you for your attention.
Thank you, Lise. That was really, really cool. Fantastic data. It looks like you have everything happening in one location in terms of hotspots and rifting and volcanism and whatnot. There is a question. There's none from the chat just now. Oh, there's a hand up from Ben. Ben, would you like to unmute and ask your question?
Yeah, thank you, Lise, for the nice presentation. My question is, do we have any system on both the Guinea and the Demerara end of the margin that shows where the carbonate platform, that's the post rift of the Jurassic opening of the Central Atlantic, the delta system that progrades and shuts the carbonate platform? Do we have that reflection on both side of the margin? And also the marginal ridge formation, is there evidence of a marginal ridge on the Demerara and the Guinea conjugate margin?
I did not talk about marginal ridges, but maybe on these sections, you can see the lateral variability of the transform margin. And you can see that in some places there are sort of marginal ridges, which are less impressive than what we can see along the Côte d'Ivoire-Ghana margin, but which could be such a relief. In fact, they are only represented in the purely transformed sections. You see, when we are oblique, the system is different with tilted blocks. And so I'm not sure to have understood your question about the sedimentary system. I imagine unit E above the carbonate platform, but maybe it's a question about where this unit is the thickest. It is clearly the thickest going toward this oblique system. It's not very clear because the upper Albian Unconformity eroded all the sediments, but you can see some thickening patterns of this unit. Also, did I answer to your question a little bit, Ben?
Yeah, I think that's fine. Thank you.
Yeah.
Perfect. And I believe Gianretto also has a question.
Yeah, my question is about where is the conjugate margin during the Jurassic?
We think it's Bahamas.
And what can you see there? Can you also see SDRs and?
I myself did not see the SDRs, but if I think that Bahamas is considered as a volcanic margin also, as Demerara and Guinea. I'm sorry, I don't have the right reconstruction I look for. No, I didn't take that in my backup, sorry. But there are several reconstructions from Pindel, for example, which make the conjugate of Demerara and Guinea close to Bahamas.
Okay, thank you.
And I think it will be the next step. There is a PhD ongoing at Ifremer at now, Thomas Lesourd. I think he will have a look to such a data, probably in connection with Total.